So the binomial theorem says that the expansion of the binomial a plus b raised to the nth power is equal to the sum of the index starting at r equals 0 to n times the coefficients n choose r times a to the n minus r power times b to the r power. Now if you expand this, you'll see that you get the pattern that we've seen developed in the expansion of the formula. We've actually seen this before. We've just never seen it written in summation notation with the sigma in the front. Okay, so this is with n choose r defined to be equal to n factorial over parenthesis n minus r factorial times r factorial. So we're going to carefully expand a plus b to the fourth power using the binomial theorem. So all we know is that we have the a plus b, and the n is going to be fixed at the number 4. So we have a plus b to the fourth equals the sum r equals 0 to 4 of 4 choose r of a times to the 4 minus r power times b to the r power. So we just replaced all of the n's with the number 4. Okay, now we're going to go ahead and calculate the expansion. So we're going to start first by letting r equal 0 and figuring out what the term is when r is equal 0, and add that to r equal 1 term, add that to r equal 2 term, etc. Let's see what we get. When r is equal to 0, this is 4 choose 0 times a to the 4 minus 0 times b to the 0. Okay, how about when r is equal to 1? Then we get 4 choose 1 times a to the 4 minus 1 times b to the 1. Which term do we get when r is equal to 2? We get 4 choose 2 for the coefficient times a to the 4 minus 2 times b to the 2 plus, what about the r equal 3? We get the coefficient 4 choose 3 times a to the 4 minus 3 times b to the 3. And finally, for the r equal 4, where we're going to stop, we add 4 choose 4 times a to the 4 minus 4 times b to the 4. Let's simplify this. 4 choose 0 is equal to 1, so the first coefficient's 1 times a to the 4th plus b to the 0. That's why you don't see it. It's equal to 1. Then for 4 choose 1, we have 4 factorial over 4 minus 1 factorial times 1 factorial times a to the 3rd times b to the 1st. For the third term, we get 4 factorial over 4 minus 2 factorial times 2 factorial. See, we're just using the formula for 4 choose, what was that? 4 choose 2 on that one. Okay, then plus 4 factorial over 4 minus 3 factorial times 3 factorial times a to the 1st times b to the 3rd. And for the r equal 4 term, we add 4 factorial over 4 minus 4 factorial times 4 factorial over a to the 0 times b to the 4th. Now simplifying further, we get a to the 4th plus 4 times 3 factorial over 3 factorial. See, I factor the top down so I can cancel, times a cubed b plus 4 times 3 times 2 factorial is going to cancel with the 2 factorial on the bottom, times a to the 4th b to the 2nd. Then plus, on the bottom we have 1 times 3 factorial over, on the top, 4 times, let's just take the 4 factorial and factor it down to 4 times 3 factorial so we can cancel the 3 factorials, times a times b to the 3rd, plus the last term is 4 factorial over 0 factorial, which is 1, you know, times 4 factorial, cancel those 4 factorials, times b to the 4th. And carefully finishing our simplification, we get a to the 4th plus 4a cubed b plus 6a to the 4th b squared plus 4ab cubed plus b to the 4th. You'll notice the coefficients that we got for this expansion are the same as the n equal 4 rule of Pascal's triangle. So it would probably be easier just to use the triangle for something like the 4th power. But what if you had the 46th power? You're going to draw a huge triangle and just to get the coefficients? No, you're going to use this method. So that's the beauty in this binomial theorem.